I want to say that I'm really honored and humbled to follow Peter Senge, who's a much better speaker than I am, but he gave me lots of ammunition in order to sort of explain this kind of stuff. So I'd like to start off with kind of explaining who I am. So I'm half engineer, started out high-tech R&D, computer science, engineering. I switched to my true love, which is psychology. So I've done the social science route and research and know how incredibly complicated things are. And then I went off on this quest to find out, can we possibly find some kind of measurement methods that are appropriate to the human and life sciences? And I didn't really expect to find anything. I mean, the best I thought we could possibly do was statistics. But I actually found that there is a group of people, I mean, this started way before me, that are making that impossible dream come true, that it is possible to have quantitative measures that are effective and don't destroy the phenomenon in human systems. That is, you don't have to cram the entire human condition into a box that is completely inappropriate for what we're trying to understand. So that's kind of what I'm here to talk about. Laura here, who is an FHI a person who's been working with me, has been helping me cram it down and simplify it so that I'm going to talk about some of the technical stuff, but hopefully I'm going to do it in a way that makes sense to you, because fundamentally, I believe this stuff is going to be common sense at some point. Right now, it just seems utterly impossible. Okay, so basic thesis: if you model complex systems like human beings and ecosystems and living organisms and economies and cities as the flow networks, you actually get a lot of things that you already know happening. Okay, for instance, in the new era of physics, things aren't made of matter, they're made of energy. So everything is made of energy, including matter. Once you have an energy basis for your understanding of how things work, you actually have an understanding of why things move, because energy is the basis of all motion. You have an understanding of why human systems and physical systems and ecosystems all respond to pressure, for instance. You find out that things like the biosphere, Peter talked about autopoiesis, which is also known as just self-feeding. So in order to, many flow networks, like a lightning bolt, they're ephemeral. They last long enough just to discharge the voltage that created them. Once that's gone, they're gone too. But the things we care most about, like economies and human beings and living organisms, they manage to survive and keep on going. And how do they do that? Well, there's several key things. One is they pump the energy that they don't just eat food and then drop dead. They funnel the energy back into building and maintaining the internal processes and the infrastructure that allows them to do more things, allows them to find food, for instance, allows them to process food, turn it into energy that they need for all the different parts of their body. So that if you, oops, do I have a, can't see it, never mind. Oh, this is going to be useless. If you want to figure out how to make any kind of system long-term sustainable, one of the things you have to do is see how much of its energy is pushed back into building and maintaining itself. So you would ask in an economy, how much money goes to infrastructure? How much goes to education? How much goes to building social community capital, these kinds of things? The things that we all know are necessary in order to get it to work. You can actually create measurements based on how much percentage of your processing, your energy, your resources, your goods, go back into that kind of thing to see how long it's likely to sustain. So, gotcha. So the idea is that there are universal laws that apply to all sorts of different complex systems, and these are not arcane laws. These are things that you see every day: pressure, circulation, pumping money back into your own well-being. Okay, so now here's the other interesting thing about complex systems, is that they tend to produce universal patterns. So the ancient Greeks looked at the world and found sacred geometries, they used to call them. These mathematically precise, identical patterns pi and phi and the golden curves that you see on all sorts of new science books. These kinds of shapes exist in all kinds of systems. So for instance, this particular, the lung shape, which is this branching pattern of big guys, medium guys, smaller guys, nonlinear dynamics background. So I call this a fractal, so that there's a mathematical way of understanding why those things emerge, and you can measure them precisely and find out how healthy you are based on what kinds of balance of big, small, medium, and large you have. But those universal patterns which have been observed for 2,000 years, we can now make are now mathematically measurable, and so you can create quantitative measures of those structures that identify them, and you can compare what your system is to what that system is, or what the optimal form is in nature. Now, the reason they exist in nature is because they optimize some sort of function. In the case of the lung, it optimizes the distribution of oxygen into the, or this diffusion of oxygen into the bloodstream. River deltas, you have different scales of the system need different scale-appropriate organisms, so that you have the big, robust flow coming down the Mississippi River, but then when you get down to the wetlands, it breaks into these fine little filigreed flows that process all sorts of, clean the water, they provide habitats for all sorts of things. So that's why the ecologists will tell you that there's a whole bunch of ecosystem services going on in those things. And if you wreck the small, fine-grained wetland deltas, your system won't work well. I actually included the ant trails in this because it sort of goes to the point that we tend to think of disorder out there in the system and perturbations going willy-nilly. But in fact, most of nature actually has this invisible hand that weaves order into it. So here's ant trails. We all know that when an ant goes out and finds a cache of food, it leaves a little pheromone trail back to the nest so that the next guys can follow. Unfortunately, about 15% of the guys who follow that trail fall off and leave a false pheromone trail. And then some percentage follow the false trail, and then 15% fall off those. So you get this kind of fractal branching pattern going on. Why the heck would that be a functional thing? Well, it turns out, and there's people who have shown this mathematically, that this turns out to be an optimal search pattern for food that is going to be scattered in the region. So much of the error, much of the diversity, much of the randomness actually feeds into natural systems that are nevertheless precisely organized and optimally designed in many ways. Okay, so what people I work with do is take these kinds of ideas and the fact that you can measure them mathematically and apply them to things like cities. So look up on the web, you will find things called a fractal city. Now, what is a fractal city? A fractal city is one that has an appropriate distribution of small, medium, and large institutions, highways, pathways for flow, all these different kinds of aspects of the city. In fact, architects will actually say that the way we structure the small, medium, and large scale ornamentation on a building will have an impact on the way people communicate and how much they feel at home in the space. So all of these kinds of things are actually in some ways mimicking the optimal forms in nature, but they also have an incredible functional aspect too, so that Nikos Salangaros, who's the guy, he's at University of Texas, Austin, who does the best on the fractal city kinds of things, looks at how self-policing, poverty levels and wealth levels, and actually entrepreneurship too, vary depending upon how you structure all of those different institutions in your city. So one of my heroes in all of this is a woman named Jane Jacobs, who was, wrote a classic book called Death and Life of the Great American Cities in the 1960s. And she was also looking at the idea that if you structure your walking paths in a way that people are going to be traveling on them naturally, so that they're natural flow paths to going to the grocery store, going to the dentist, going to wherever you go on a natural, regular basis, and you structure those in a way that's safe and convenient and comfortable, then you're going to stimulate things like conversations with your neighbors, a greater sense of ownership in the space, these kinds of things. And this will have a dramatic impact on whether or not, if a community feels like it owns the space in which it lives because it feels comfortable, it feels like it knows who everybody is, then it will tend to do self-policing. They'll say, who is that guy and why is he taking that little girl over there? Now, it may be the father who's just trying to take his kid away, but people who know the space and feel an ownership for it will tend to ask that question. And if they don't know the person, more than likely it may be something problematic. So having scale-appropriate structures in a city goes a long way in making sure that all the critical city functions happen. Now, one of the things that I've been doing with Bernard Lietaer, who's a Belgian financier and banker, is to look at what we call the Goldilocks rule, which is that you need, in banking in particular, you need institutions that are just right for each scale. So you need big transnational banks that handle those big global transactions and currency exchanges and things like that that have to happen on a massive scale. But you also need regional banking that will facilitate the flow of finance into regions and be specific to the kinds of markets that they face and what kinds of needs they have and what kind of potential they have. And you particularly need a whole bunch of very small-scale local banks who know their markets, know their clients, know their customers, and who have a vested interest in funding those people and the success of those kind of small commercial loans. Now, if you have what we have now, which is this hyper-emphasis on efficiency, so that bigger is better and economies of scale, and so we don't really have small independent local banks anymore, and we aren't doing very many small commercial loans anymore, at least not at the grassroots level, because it's not economic for a gigantic bank to do $50,000 million loans. It's much better for them to do one $50 million loan. So there's economies of scale problems that why wealth is not, or finance is not reaching the lower levels. And there's also a lack of incentive because they are not grounded in the local community. They don't have a vested interest in the success of that loan. So you get things like derivatives. So if you, using fractals, you can say that if you don't have enough diversity and relative autonomy of small local banks, or same thing at regional banks, then you're going to have less economic health. Your system is going to be not circulating properly because the money isn't going to reach down to the grassroots and these kinds of things. You can see that people are now attempting to remedy this kind of problem because we now have a lot of we have a banking system that just does not address many needs. And so we have microloan systems, and we have a push toward public banking, and we have complementary currencies, and we have all these different attempts to find out how can we get financing down to the small-scale root system. All of this just makes complete sense from a fractal point of view of how healthy structures are structured. Okay. Now, the particular paper that I did that Paul got me involved with, found that is this paper on quantifying economic sustainability. So everybody has heard the term resilience, right? Very popular topic. Right now, there are a billion different definitions of resilience and no established quantitative approach to it. But this is one way of approach that's coming out of the studies of healthy ecosystems. All right, so if you think of resilience as the ability to spring back, what kinds of things go into having a resilient system, ecosystem, or economy? Well, you need diversity of options, so that if something goes wrong with your main employer, you have other people to do employment. You need flexibility to make those choices. You're going to need, you're going to be small, diverse, and flexible. It's going to be an important part of having a resilient system. On the other hand, in order to be healthy for long term, you also need to have big and efficiency and focus. You need to be able to pull in resources. You need to tap into the demand going on, and so that the global economic system will flow towards your little place as well. So that you need both the big and efficient and focused and the small, diverse, and flexible. what you can find in natural ecosystems is that they all maintain a balance of that small versus large in a particular range, which we call the window of vitality. And long-term health really depends on being able to balance those two kinds of things. Because if you have too many small, diverse, and disorganized institutions, you get stagnation. You get a traditional subsistence economy where, you know, everybody knows each other. There's lots of small organizations, but there's very little focus and power to pull in new resources. On the other hand, if you have too many big, efficient, gigantic guys, what you'll have is what they call a positive feedback loop, that you'll pull resources in from the ground up, and it'll concentrate at the top, and you'll tend to create brittleness. You'll kill off lots of the local, small grassroots businesses. At the same time, you'll have wealth concentrated at the top, but not circulating well. So anytime you see, for instance, a growing gap between the haves and the have-nots and a shrinking middle class, that's a sign of what we call economic necrosis. It's poor circulation, not an improper balance of small, medium, and large, and essentially slowly but surely eroding the economic root system. So, and all of this can be put into nice quantitative measures, and the measures are actually relatively straightforward to do because they have a lot to do with counting the diversity and size of organizations, where flow goes, volumes of flows, these kinds of things. So a lot of research is now being done. In fact, Laura is going to talk in a minute about a project we're trying to start with FHI 360, using existing data sets. So you may not need to collect new data sets. There are, you may be able to get by with, certainly economic flows are well researched, and there's immense amounts of data on it. So now there's another aspect. Here's another. I'm just going to give you two examples of patterns. The second pattern is what I call intricacy. So if you look at things in the real world, it's never, all big things are made of smaller things, which are made of smaller things still. All right, so your body is made of little cells that are organized into organs that are organized into bodies, okay? And the way that the embryo shows the kind of the thermodynamic reason for it growing this way. So what happens with an embryo from a thermodynamic point of view is one cell gets bigger and bigger till the bonds holding it together get stretched to the breaking point. They literally fold into two that are smaller, tighter, more efficient, better connected, and then they couple together, and then the process repeats. And so you get this, over time, you build these lace-like networks of interconnected circles. And there are certain rules about how that works. In fact, that getting bigger and splitting is called the surface volume law in biology, and it's a precise mathematical place where that break takes place. So you can use these kinds of things to measure how well, okay, if your system has intricate social fabric, lots of those little small circles, all kind of synergetically intertwined, they will be circulating faster, as we shall see, and they will be more robust, they will be more productive, they will be, there's a whole long list of these kinds of things. So you can use these kinds of ideas to differentiate between a bubble economy, which GDP is growing massively, but the wealth is not circulating robustly throughout. You don't have a whole lot of grassroots enterprise or not sufficient grassroots enterprise to really hold up this processing and provide the diversity of roles that you need in order to really get it going. And you will lack kind of ownership properties for people. People tend not to feel very much ownership if you're in part of a large corporation. They're much more likely to feel that way if you're in relatively small companies, depending upon the culture of the company anyway. So here's an interesting and, I understand, a controversial slide, which is there's a guy in Harvard and Tufts, physicist Eric Chasen, who talks about the rise of complexity. So if we look over time, if we imagine evolution not just being about biological evolution, but the evolution from origins of matter, from plasma forming into subatomic particles, forming into atoms, forming into molecules, forming into dust clouds, forming into galaxies, forming into the emergence of life, there is a kind of a stair-step progression of increasingly tight intricate organizations happening. And Eric, who does, what does he call it? He calls it cosmic evolution. I tend to call it dynamic evolution. But it's basically looking at how physical energy flow processes create a natural understanding of why things become more complex. He's measured that. So you can actually measure the internal complexity and intricacy of a system based on how fast it circulates energy per unit time per unit density. So in this case, the unit of flux density is ergs per seconds to -1 to grams to the -1, but you can use a multiplier effect for how much money circulates inside a local economy to get basically the same idea. And what you find is that the more advanced you get corresponds also to the higher internal and energy circulating or resource circulating as well systems. So this is all to say that, yes, it is possible to measure how things get more complex, and precisely so. And you should be able to actually create a metric that tells you what stage of development you are. So in this case, hunter-gatherers' level of organization is clearly less it circulates energy slower than agriculturalist civilization, which circulates energy slower than modern civilization. So the upshot of this is a new understanding of how scientific methodologies work. All right. So this slide comes to us from mathematician Warren Weaver, who was writing, and get this, in 1947, he wrote a seminal paper called, Science and Complexity. In fact, it was one of the early usages of the term complexity. And what he said was that science evolved through 2 stages and was on the cusp of a third. The first stage, which is classical determinism and Newton, we looked at how one thing caused another. So in Newton's case, he looked at how the huge gravitational effects of the sun determined precisely the movement of the itty-bitty planet. And it was only worked because the gravitational effect of the sun was so huge that it really did determine the movement of a planet. And it's very precise, and it's the gold standard of physics. On the other hand, most of us are dealing with systems that have many causes, and they're all very balanced, and it's very hard to pick out any one cause as the cause that's going to determine how everything works. So sometime in the 1800s, they went to the opposite extreme, and some brilliant people figured out that if you have lots of relatively same-sized bodies and they're not very tightly connected, then you can do statistics, and you make assumptions of randomness, and you know how this all goes. That's another great and wonderful form of science. Unfortunately, it's only applicable to certain types of systems. Just like simple systems have singular causality, disorganized complexity, which is what Weaver called it, have relatively balanced and relatively disorganized complexity, randomly colliding. On the other hand, most of the world fits into this third category, which Weaver labeled organized complexity. So that when we look out at your body, yes, it's complicated, but it's also highly organized, highly structured, and it has patterns to it. And that's actually true of most things. I mean, even in psychology, there are typologies and all sorts of patterns that people recognize in human systems. It's just difficult to figure out how to capture those in a way that is effective as a measurement system, partly because they are so diverse. So what we are dealing with here is not just complexity, we're dealing with organized complexity, and what we're trying to do is use, you can call it biomimicry, you're trying to use the universal laws of physics that explain why these universal patterns exist, and then use those patterns as targets for healthy growth. So that if you go to your banking system and you realize that you have 5 major banks running 99% of the world's economy, you can tell that you're over-concentrated at the top and you don't have enough diversity and enough distribution of wealth and autonomy throughout that system. Okay, so takeaway. There are better ways to understand and measure systemic health. Understanding nature's laws of healthy development can help us build better networks. Buckminster Fuller was right on this kind of stuff. Right now, we feel like we're victims of our own creation in many senses. I mean, Peter was talking about the fact that human systems are largely governed by your culture, your thinking, your belief systems, your habits of thought, and your assumptions. And we somehow believe that what we think now is inevitable and sort of like, or maybe the optimal way to think. But of course, there's huge amounts of evidence that that's not the case, right? What this does is helps us give an understanding of how to guide our thinking in a direction that's likely to make free enterprise networks, which is my current hot topic, into healthier systems themselves. How much time do I have left? 5 minutes. Oh, I have to go over, Laura. I'm going to show you one. The upshot of all of this is that right now we have a view of economies where people feed into the economy, which feeds into growing money. What we really need to do is change that upside down. So we see money as a critical facet of greasing the skids, and it's like blood. It's fertilizing the economy, but its main emphasis is building healthy economic webs, human networks. That's it. And so now for my last 5 minutes, only 4 now, Laura Goldman and some of my folks are working on doing an actual research project, and we had a discussion last night to kickstart that. So I want to give her a chance to talk about that and say how she sees this work as impacting on development measures.
Thank you, Sally.
You're welcome.
It's been a real pleasure. I think I was just thinking that I met Sally back in May at a one-day event that Paul Bundick organized in Durham, and it's been a pleasure getting to know her and getting to think about how to put some of these ideas into practice. And she gave me these minutes. She was actually not forced to do so. And my job is actually to link, to try to bring that link between Sally's the principles and the ideas that she is talking about and the work that many of us do. So I'm going to attempt to do that, and I'll explain how this research that we're getting started should attempt to do that. But think about that as kind of my first cut, as a kind of collective, draft at what are these measures. So I guess after spending a day in Durham with Sally and a number of other colleagues of Paul's that had been working on systems and resilience, yes, there was a lot of excitement about, and certainly an assertion coming from the systems people that this is science, this is math, and you can measure, things. And I was like, okay, fine. We can certainly measure, and by the way, the banking slide, my first question on the banking slide was, is there an empirical study behind that? Intuitively, anybody who's worked in microfinance and anybody who's worked in sort of financial inclusion understands the principles that you want to have a banking system with, a good distribution of sizes of banks and sizes of loans and different financial products. But, there actually isn't a study that's been done that links both the scientific piece and the sort of economic numbers. So there's one right there. I was like, okay, there's a study that could be done. This would be great. This would be really interesting for people who work in financial services. There are a number of these different pieces. I think, the way I would frame it and the kind of big picture overarching idea I would use is inclusive growth. Looking around the world now, what are economic policymakers in developing countries looking for? They're looking for growth with jobs. They're looking for growth that is not only rapid increases in GDP. But what I like about this is it's not only, saying we want environmental sustainability or we want resilience. It's a broader concept, and it's a different audience. I see our audience when I talk to Sally and I talk to her colleague Brian Fath, who's at the University of Maryland. I see our audience as economic policymakers that want to hear the business case, and they want it measured. But the business case for why would you want in an economy a distribution of small, medium, and large firms? Again, that's intuitive to many of us who have worked in enterprise development. A distribution in a value chain. Are there things we can learn? And I was sitting in Jean Downing and Ruth Campbell's session this morning to try to kind of make some of the links between the work they've been doing and some of this thinking. We talked last night about in a value chain, would you measure product flow, money flow, social networks? Mike Field in Kenya, I think, has been looking at this and thinking about, how do you measure social networks? So I think we're at the stage where it would be great to use these measures in our projects in ways that they're maybe directly useful to us, but cross them and get those insights and come out with our our set of, what are some good proxies for what's an inclusive economy, whether that's at the national level or the regional or at a sector value chain level. So that's sort of the challenge I wanted to throw out and the kind of crazy idea. And another, just one of the ways that this came to me, can I call that curve that you showed, the Warren Weaver curve? I did not know he invented that. So the Warren Weaver curve that shows you a system and has dots on the top of it, which is where a healthy system should be. So the first thing that spurred my excitement about this was Brian Pfaff at the University of Maryland has, with a couple of his students who've gotten some economic data at the national level, have plotted economies. Where are they? And there's this one side which is on the sort of efficiency side, maybe too fragile, maybe too many big actors, too well organized, and then the other side sort of more diversity, maybe messier. And where would you think, he plotted the OECD economies, so where would you think they would be? So, well, maybe intuitively a lot of us thought they'd be on the fragile, the big side. They weren't. They were a little bit over towards the more disorder side, and that's OECD economies. So think about the economies we work in. I'd love to plot those. I mean, that was the very first thing that I, when I saw that, I said, we've got to get some developing country data. So, and Alec Hansen, who's in the room as well, is going to work on some of this research, so you might also want to participate in the conversation. But I just wanted to throw it open, and you guys can choose to also go in a different direction. I think there's a lot of the ideas that Sally put out there that may resonate with, different projects and different disciplines in which everybody's working.
Okay.
And how does the microphone work? Are we going to give it out, or do people just stand up?
We have microphones out here for folks that are super excited by some of the stuff that's been put out here, or have questions or thoughts. There's microphones there and there.
Good. Let's give people a minute. I always find sometimes with like these big ideas, you gotta, and yeah. Walt?
Thank you. I'm Bruce Waltuck, and I wanted to ask how you can identify and perhaps manage the conditions that are necessary and sufficient to achieve that kind of vitality and organized complexity that you talk about.
Okay.
Thanks.
So I will say that one of the reasons I like working with Laura is because I'm good on the what, what would be healthy. I'm not so good on how you get it to be healthy, which frankly I see as your work. I think that's what you guys are specialists in. You're trying there. What I can help with is what Laura said, which is that I believe that there's a case that can be made to economic elites that everybody's going to be prospering better if you understand the rules of what makes an economy sustainably vibrant, and that you create policies that will push it in that direction. Because right now, obviously, we have this love affair with GDP growth, we have this love affair with high efficiency, and all of that does is push us towards the brittleness and collapse. And we see all sorts of signs of that. Just knowing that, okay, and the other thing that's nice about this is that it's not that big is bad and little is always good. It's a more common sense approach that we need small, medium, and large. We just need them in the proper balance. So it's the extremes that cause problems. Okay? So what we can do is provide both a framework and measures that are going to help policymakers make choices that are going to move it in the right direction. That's the best I can do.
So we've got one over here, and then we've got, I guess, Monica, go.
All right, so one of the questions I have, Sally, is the role of feedback loops. So I think about our bodies, or my body, as a complex system that is organized. Yes. When an invader hits it, like a bacteria gets in, my body all by itself sends all the little soldiers it needs to go take care of that. And, right. I either get sick or don't get sick, but sooner or later it restores itself into balance.
Right.
What are the feedback loops in our economic systems that would allow us to respond the same way? What might they be?
It's supposed to not be controversial. which is hard
No,
for me.
no, you're allowed now.
I'm allowed now? Okay.
We had a talk with Sally about that you guys are so smart that you're going to get to conclusions yourselves and not to start the presentation with some of perhaps her conclusions. But now Q&A.
Okay, good.
Let loose.
Thank you. Let's see. So feedback loops, absolutely important. And also know that you need a balance of positive feedback loops, which are the ones that accelerate growth, and negative feedback loops, which are the ones that dampen growth down so they don't do overshoot and go out of bounds and have pops. And human systems have a huge number of these feedback loops on both kinds. I mean, when we try to stimulate the economy, that's what we're trying to do. We're trying to stimulate growth and get a positive feedback thing going. When we build little entrepreneur circles, that's what we're trying to do. Get those little circles and growing kinds of things. This is all fine and wonderful. The problem is that because we've had such an emphasis on the large and the efficient, that we've got this concentration, and that we also believe that self-interest is all you need, so that a lot of what happens is that the guys at the top who have all the money and power they need pay money to buy politicians to pass laws that are beneficial to them, which is only to be expected. But on the other hand, it's damaging. There isn't sufficient feedback damping on the upper levels. And as a consequence, democracy was supposed to be the ultimate feedback. It's supposed to be really government of the people and by the people and for the people. But if you get to become a plutocracy, which it's increasingly looking like the US is in particular, then you don't really have democracy and you don't have adequate feedback mechanisms. So that's my 2 cents on how do you do it. Well, here's the other thing. I do a lot of studying of the cycles of civilization, not only collapses, it rises and falls and things like that, but also transformations. So both of my books, most recent books, have a lot to do with how our times are similar to the change from medieval to modern society. We went through the Renaissance, the Reformation, the Scientific Revolution, and the Enlightenment, and once those things came together, there's a whole bunch of pressure, a whole bunch of diversity of thinking, new novelties coming up. They coalesced into a completely different type of system, which made huge advances over what was previous. We're now, from my point of view, going through a similar kind of period where pressure's on because things are not working in many ways. There's lots of innovative thinking going on. I can tell you for sure that it's taking place in absolutely every field you can imagine. I mean, I gave a similar talk to this, to the advertisers in Madison Avenue conference about 10 years ago. And I got a bunch of them coming up telling me how this kind of stuff is taking place in advertising and marketing. And you're going, really? But anyway, so it's taking place. And I believe that if we can come together quickly enough, we will have another major transformation of the order as from medieval to modern, now from modern to integral society. But I kind of lost track of what I was talking about.
I think we're good.
Okay.
Another question here?
Thanks.
I'm going to resist the temptation to talk too much about feedback loops because I meant to do that in the morning, all right? But I think, so I meant to be talking about feedback loops tomorrow morning. But, two points really. One is I think one of the issues is how do we get interpretive feedback loops from large human populations? And traditionally elections has been one way of doing that, but because the agents are no longer independent of each other, you get the plutocratic reinforcement of patterns through things like opinion polls in the press.
Right.
And that would lead logically into dominant predator theory in ecology, which says if the ecology is, you've now got to the point where the sort of neoliberal large groups are now a dominant predator, the rest of the ecology is reorganized around them.
Right.
The only way for that pattern to break is actually catastrophic failure of the ecology to allow something new to come through. And I've yet to find a way around that, though I keep trying to think of one.
Well, and actually, that was the end. I had lost track of what I was saying, but okay, if you look at the last shift, the Renaissance, the Reformation, there were a lot of elites involved in all of this kind of stuff, and there are lots of elites interested in making this kind of a transformation. So I don't. Okay. It's not necessary to go through a collapse. I really believe it's not necessary to collapse. That we are actually, from my point of view, a collaborative learning species. And we just kind of get, once we come up with this new idea, new world hypothesis, as one guy calls it, we get stuck in it. But we're really sophisticated now, and of course we're also very locked in. But I think that if the right, what's the metaphor? The trim tab metaphor. How do you turn a battleship? They have this huge 12-foot rudder on the back, but you can't change it because there's so much momentum holding it in place. So, but they've got this 6-inch thing on the end called a trim tab, and you can turn that because there's not that much pressure on it. And once you do that, it kind of creates this momentum effect that turns the whole thing. I think that we need to get our trim tab in order, basically. Other questions?
Great question, great question. That's fascinating talk. If there's not any more questions, I think we might take a little break and join me in a round of applause for a fantastic conversation. Sally Goerner, Lara Goldmark, fantastic.